Okay, welcome back. So in this class we will be discussing about functions. So we have already done relations. So what we'll do is this, we'll do the theory part in this video, and in live session we'll do the questions related to function. Okay, so we'll start with function. Function is one of the most important part of mathematics. It's a very nice concept, and it can be like it can be it can be realized as a special kind of a relation in the first place, and second, it can be realized as a machine also, which take a input and give us a output. Okay, and functions are sometimes called maps or mappings too. So we can go to the definition 5. So you can see a relation f from set A to B is said to be a function if every element of A has one and only one image in the set B. Okay, this is the definition of function. Okay, so what it means is this: if we know that relation is a relation from A to B is just a subset of A cross B. So means the function f will be a subset of A cross B. Okay, but with this condition that every element of A has one and only one image in B, means that domain of this relation f must be A. Okay, and you cannot have two elements with first element same in the relation. Okay, so you can just see, in other words, a function f is a relation from a non-empty set A to a non-empty set B such that domain of f is A and no two distinct order pair in f. As f is a subset of A cross B, its element will be of order pair, so no two order pair of f has same first element. Okay, that is the thing. Now if we consider that f is a function from A to B and AB belongs to f, so if AB belongs to f, we write what? F A equal to B. Means this notation AB belongs to f is changed to this one, so we write like this. So if this is given, if f A equal to B, in terms of Cartesian product of sets, we should think that A comma B belongs to f, where this B is called image of A under f and A is called pre-image of B under f. The function f from A to B is defined by this notation: f A arrow B, means we have a function from A to B, means what f is a subset of A cross B. Okay, with a special property that domain of f is A. Okay, looking at the previous example and this is the thing, so we can just see, and let's go to the example number 10. Okay, let n be the set of natural numbers, then the relation R is defined on n such that R is what? Xy, y is equal to 2x for xy belongs to n. So what is the domain, codomain and range of R? Is R a relation, a function? Okay, is this relation a function? So you can see that R is a relation, so I have to check whether it is a function or not. So y equal to what? 2x, and x and y belongs to n. Okay, so we can just see that in this R, if you take any x is a natural number, y is a natural number. Whenever you take any x can be here, right? For any x you can find y, 2y. Okay, if x equal to 1, y will be 2. If x equal to 2, y will be 4. So you can see that. So every natural number can be a element of domain for this relation R. Okay, then the product, the result is always it's giving only one result. Okay, when you multiply this x by 2, you get a unique number. Okay, so you can see that domain of this R is a set of natural number, and codomain is also set of natural number. There's no problem. Codomain is a set where it is going. Okay, and range is a set of even numbers. Okay, since every natural number n has only one and only one image, okay, this relation is a function, because when you multiply a natural number by 2 to get a fixed number. Okay, you don't get sometimes it is one number, sometimes it's other number. For example, 3. If x is 3, you'll always get 2 into 3 is 6. You are not going to get 7 or 8. Okay, this type of things doesn't happen. So therefore, this is an example of a function. Next example number 11. Examine each of the following relation given below and state the case whether it's function or not. Okay, here R is given to you. It is what? 2 1 3 1 4 2. Okay, you observe this. So this is a function which what will be a domain? 2 3 4. Okay, it is a function. The second element can be same, we don't care. Only the first element we cannot have two ordered pair with same first element. Okay, so this is a function. So here you see you have a element where the first elements are same, two ordered pair with first element same. So therefore this is not a what? Function. Okay, so this is a relation. You can see this is a relation. So is this a function? You just check 1 2 3 4 5 6. Okay, this is a function. Okay, every element has one and only one image, so this is a function. So next definition: a function which is either which has R or its subset as range is called real valued function. Okay, real valued function is what? A function which is going to the real numbers. Okay, means whose range is R or its subset. Okay, so further its domain is also R. Further with this if the codomain is R, we say it is real valued function, and if the domain is also R, we call it one real function. Okay, so here are a few examples. Let n be the set of natural numbers. We define a real valued function f n to n with this. Okay, because n is a subset of real numbers, so it is a function from going from subset of real number to real number, so it is a real function. Domain is also a subset of R, codomain is also a subset of R. Then you can see you have to put the values, find the values, what will be the value of f1. Okay, so put the value to get a value of f1, you just have to put 1 here. So you put 1 here, so you get 3. If you put 2 here, you will get what? 5. Okay, because 2 into 2 plus 1 is 5. If you put 3, for 3 you put a 3 here. Okay, f3 you'll get f3. F3 will be what? 7. Okay, like this you can just go on doing. Next, few function and their graphs. Okay, this is the topic with function with their graphs. So what we'll do is we'll see the function and we'll try to draw the graph. As we know that we are in ordered pair, a function is a set of ordered pair, right? It's a subset of a Cartesian product of two sets. So let R be the set of real numbers. We define a function f R to R. So we have already called that this is a function. And what is the function? Y is equal to x and fx is equal to x. Okay, so fx is equal to x is a function. So what will be the points here? Okay, means what? If you put 1, the value of fx will be what? 1. If it is 2, value of fx will be 2. If it is 3, it is 3. If it is 0.1, the value of fx will be 0.1. So we can just say that this function is called what? Identity function. When it doesn't change the value of input, if a function doesn't change the value of input, we call it what? Identity function. It can be from any set A to set A. Okay, so here we have an identity function on the set of real numbers. So here domain of f and range both are R. The graph is a straight line. You can just draw this. Okay, it will be a straight line. So it's like this 2 2. We just put it 4 4. Okay, 5 5 6 6. This will be the points in this R, because their definition of R is what? Y equal to x. So x. So whatever x is, that will be the y also. So that is the thing. So this is the identity function. Okay. Okay, next set of functions which are very common in mathematics is the constant function. So it is defined as this: f is from R to R. But what is the value of y? Y will be c. For any x, y will be c. C is a fixed real number. So if you put any value in input, the output is always the same. Okay, it is C. So we fix that C, then we'll get a function. For example, if C is equal to 1, so if you put 1, it will be the value of y will be 1. So if it is 2, value of y will be 2. If you write this thing, if you try to write this thing, so you can see r will be what? R is equal to the set will be 1 C 2 C, like this. Whatever you put, minus 1.1, you'll get what will be output? C. If you put square root of 2, what will be the output? It will be C. Okay, this function is called what? And this function is what? If you have a function like this, so we call it, so if we call it what? Constant function. Okay, so I think this should be f actually. Okay, so this is the constant function. So you can just draw the graph. 1C means like this, 1C, 4C, 6C. So this is the C. Okay, so whatever it is, wherever it is. Okay? If C is 4, it will be, graph will be like this. If C is 5, graph will be like this. If C is minus 2, the graph will be like this. Okay, so the graph of a constant function is always parallel to x-axis. Okay, next set of functions which are very important is this polynomial functions. Okay, polynomial functions. So what is a polynomial function? Polynomial functions are functions from R to R, and it is said to be a polynomial function if y or fx is given by a polynomial. Okay, when fx is a polynomial, we call it what? Polynomial function. That's a polynomial, you know, it's like an algebraic expression where this a0, a1, a2, an are what? Real numbers, x is the unknown, and n is what? A non-negative integer. Okay, means non-negative integers means what? It's natural number. So this is the thing. Okay, so you can just see this is a fx equal to this. Okay, this is a polynomial. Well, you know polynomial, we have studied about polynomial earlier. So fx equal to this is a polynomial, this is a polynomial. So if this is a polynomial, when we write this gx equal to this, so this became what? Polynomial function. This is a polynomial. Okay, and if we write like this, so this will be what? A polynomial function. Okay, so this is a polynomial function. So if you don't write this, so this will be what? A polynomial. And if you write this thing, so this became a polynomial function. Okay, so you can see this is not a polynomial function. Why? Because this is this exponent. Okay, this exponent is what? It is not a natural number. Okay, exponent should be a non-negative integer. So it is not a non-negative integer because this is a rational number. So therefore, this is not a polynomial function. Okay, so this is the thing. So next so here we have to complete the table actually. So you have to find out the values. Okay, here y is given by what? X square. So you have to complete this table. So you just see y equal to x square. So these are the values of x. So what will be y? You just put in. So if it is 0, it will be 0, 1, 1, 2, 4, 3, 9, 4, 16, like this. Okay. So if you put like this thing like this, and if you try to draw the graph of this, okay, draw the graph of this. Okay. So the graph is this one. Okay. So what is the domain? Domain is x belongs to R and the set of real number. And range will be also like this only. Okay. This what will be the range? Range is a positive real number. It is not going to be negative, so it will be the positive real number. Okay, and this is the graph. Okay. So you can just plot in the values of all these points. Okay, all these points. Okay, and try to connect this thing. Okay, so you will get this sort of graph. So this is a graph of what? Fx equal to x squared. So you try to remember this. This will be helpful for you. Okay. Next, so you have to draw the graph of x cube. Okay, fx equal to x cube. So you just put in few values and plot them in this paper in this graph. Okay, so point will be like 0 0 1 1 minus 1 minus 1 2 8 minus 2 8 3 27 minus 3 27, like this. You just put in like this. So your function f is what? X comma x cube. X belongs to R. So this is the this is the notation. What notation? This will be our Cartesian product notation of the function, okay, as a subset of Cartesian product of set R cross R, okay. So if you draw the graph, you will get this point, this graph, okay. So you start with like this, you just draw like this. So a point, what is the point? You just try to divide this thing like this, okay, and you put the points, okay. So it will be like something like this, okay, or I don't know, okay, it will be like. So you have to get some half and 1/4 also. For example, what will be the image of this? f.2. So this will be what? 0.2 into 0.2 is 0.08. Okay, so like this. So therefore this graph is a little bit flat in this part, and after that it increases. Okay, up to 1, it is like flat. Okay, here also same thing happening. Okay, so that is the thing. Okay, so we have something called rational function too. What is a rational function? Here functions are like fx by gx. Whenever you have function of this type, fx by gx, where fx, gx are polynomial and gx is not equal to 0, the points x where gx is not equal to 0 is the point of domain. Okay, so you have to take out that point. Okay, so here you see, define a real valued function fx equal to 1 by x. It is from the set, you see, this is from the set, not R to R. Okay, this is not from the set R to R. The domain is what? R minus x 0. So we have taken out this. Okay, so whenever you have a rational function, you have to take out the points where denominator becomes 0 from the set, from the domain set. Okay, it cannot be in the domain. Okay, you have to make sure that the points at which gx is equal to 0 is not in the domain. Okay, so this is the thing. So you have to complete the table. I think that's not, completion of table is not a big task. You can do it. You have already done it in your earlier. Okay, next important example of function is the modulus function. Okay, this is very important. What is the modulus function? So this function is defined from R to R, and it is denoted like this. Okay, it's denoted like this, and is the notation. Okay, this is the notation. Fx equal to 2 line, inside that you have to put on x. So for each value, real number x. Okay, this is called modulus function, and for each non-negative x, fx is equal to x. If x is non-negative, fx is equal to x. If x is negative, the fx is equal to a negative of the value of x. Okay, that's what, whatever the value of x is, it will be the positive value. Okay, so this is the thing. Fx equal to x for x greater than equal to 0. Okay, there is no problem. If x is equal to greater than equal to 0, it will be x only, and it will be minus x if x is less than 0. Means if you have to find the modulus of what? Minus 1. Okay, so what you have to do is you have to use modulus 1 minus 1. So minus 1 is what? X is less than 1. So this will be minus of x. So this will be actually minus of minus 1, which is equal to 1. Okay, so whenever you have a number which is greater than 0, you have to use this formula to find fx. If you have a number which is less than 0, you have to use this formula to find fx. Okay, so this is the graph of modulus function. Okay, so this is like a v. Okay, this like this part is the identity function from here to here, and this is the mirror image of the identity function. You can just see. You just put a mirror here, so plain mirror. You can just see. Okay. Next, you can go to the signum function. Signum function is just defined like this only. If x is greater than 0, it is 1. If x equal to 0, it is 0. If it is x is less than 0, it is minus 1. Okay, this is also a very important function in your school, in your course. So you have to know, and it is very important. These names are very important for your entrances also. So try to remember this so that you can do well. Okay. So if you draw the graph of this, so you can see the range of this thing is only 3. There are only 3 possible values of fx. It can be 0 when x is equal to 0. It is 1 for x greater than 0, and it is minus 1 for x less than 0. So this is the thing. So this is the graph of function. So here this line is excluding the point in the line means we are excluding the point 0 1. 0 1 is not in this graph, and after that you will have a ray. Okay, it will be 1 for every other real number greater than 0. It is minus 1, and 0 for 0 it is like this. Okay, so this is the graph. Okay, so here is another notation for the signum function. It can be written like this. Okay, signum function is this. But if x is not equal to 0, it should be like for x, here it should be okay, x not equal to 0 should be there, so that we have a printing mistake in this part actually. So this should be x not equal to 0. If x is not equal to 0, this is the value. Okay, it is like this, modulus of x by x. Okay, okay, and is 0 for x equal to 0. Okay, so this is the thing. So you can just find out this, what will be the value. Okay, for example, if you put x equal to 1, so x equal to 1, what will be fx? X equal to 1. So you just put modulus of 1, sorry, it should be 1 and 1, right? So this will be what? Absolute value of plus 1 is 1, so 1 by 1 is 1. So if you find a function value of, for example, f minus 2, if I have to find signum function of that, so this will be minus 2, absolute value of minus 2 divided by what? 2, minus 2. Okay, so now you can just see absolute value of minus 2 is what? Minus of minus 2 divided by minus 2. So minus of minus 2 is 2, and this is minus 2, so you cancel it, so you will get minus 1. Okay, so therefore signum function of this, what we know that x is minus 2 is less than 0. So from earlier definition also, f of minus 2 should be what? Minus 1. By this definition also, f of minus 2 is what? Minus 1. Okay, so that is the thing. Next, you can go through this greatest integer function. What is greatest integer function? Try to understand this. Okay, as this is part of your class 11, so I'm leaving it for you. Okay, so algebra of function, you can just see if you have two functions f and g with same domain x, and r is the set of real numbers, codomains are r. So if you have two functions like this, we can make the third function from this. Okay, so we can make the third function. What will be the third function? This will be our third function. Okay, third function is written like this. Okay, x plus y equal f plus z. Okay, f plus z will be a function from x to r. Okay, and definition of x plus z, what will be x plus z? So if you want to find absolute value of x plus z, what we'll do is f plus z, this you see, f plus z of x, this is what? Fx plus gx for all x. Okay, so this is the thing. As we know that for all value of x, fx is defined as f is a function from x to r, and gx is also defined because g is a function from x to r. So we'll just define f plus g of x as fx plus gx. Okay, it's a natural definition. So this is the name of the function. Okay, this is like f and g only. It's like h. Okay, so but to write this, and we write like this fx plus gx because definition of fx plus gx depend upon fx and gx. Okay. Similar to addition of real functions, we can also define subtraction of real valued function like this. Fx minus gx will be what? Fx minus gx. Okay, where this fx is a function from x to r, gx is a function from x to r. So we define fx minus gx from x to r like this. Okay, this is the definition. Okay, whenever you have to find fx minus gx of x, okay, so this will be what? You see, fx is a function from x to r. This is x and this is what? R. Okay, so this is a function like this. It's going from this to this. Similarly, this is f. Okay, similarly you have z. G is a function which are taking value of x to the set r. Okay, it is also like going like this. So this fx minus gx this is also a function from x to r. Okay, you don't confuse with the notation. Okay, it is just a function from x, function from x to r. Okay, it's like from given two function we have constructed the third function whose functional value is defined with the help of the functional value of function value of f and g. So this is the thing. Okay. So multiplication is also multiplication by scalar. If you have a function fx from x to r, real value function, if alpha is a real number, then we can form another function which is what? Alpha f. Alpha f is also a function from what? X to r. This is r, so you have a function. This is what? Alpha f. Okay, so the definition of alpha f is what? Alpha f of x is what? Alpha into fx. Okay, we are just defining this thing with the help of the given function. Here fx is given, so we're multiplying this. Here fx gx are given, so like this. Multiplication of two real valued functions. If you have a real valued function f and g from x to r, so domains should be same. Okay, so then fx will be f in g. Fg means f into g is a function from x to r. Okay, and it is defined like this. Fg of x is what? Fx into gx. That's all. Okay, this is called what? Pointwise multiplication. Sorry, this is the pointwise multiplication of functions. Okay, so this is also like this only. You have a x here, you have a r here, so here this function will be what? Fg. Okay, like this. Okay, so this will be a little bit clear after some examples. Okay, like this, quotient of functions are also defined. Okay, but in quotient of function you have to remember that this domain of f by g changes. It changes to what? Where g is not equal to 0. Okay, where g is not equal to 0. That is important. So here f and g are the real valued function. X is a subset of r. It is given here. So we can just say that. Okay, we'll define f by g of x as fx by gx, and what gx is not equal to 0. Okay, that is very important. We will go through the examples very quickly, and we'll see what are the examples. So here x is given by fx is given by x square, and gx is given by 2x plus 1, and we have to define what is fx plus gx, fx minus gx, fg of x, f by gx. So you can just see fx plus gx will be what? This will be fx plus gx. So you just put in like this. Okay. Okay. But from the definition only, what is fx plus gx? F plus g of x. This thing is what? Fx plus gx. But fx is equal to what? X squared. It is given. What is gx? 2x plus 1. So this is what? X plus gx. Similarly, fx minus gx will be this. And fx into gx, you know the definition of fgx. Fgx is equal to fx gx. But fx is what? X squared. Gx is what? 2x plus 1. So you just multiply this thing, 2x cubed plus x squared. Okay, like this. Okay, similarly, this is what? F by g. But here you see, it can be 0, right? 2x minus plus 1 is equal to 0. So this function f by g of x is not defined in this point. Okay, so excluding this point, x equal to 1 minus 1 by 2, at every point this is not equal to 0, so this function can be defined. But at x equal to minus half, what happened? This function is not defined. Okay, so therefore we have to exclude this point. So whenever you have a quotient function, you have to remember that this denominator cannot be 0. So from the domain we have to, the domain should not have this points where this denominator became 0. That is important. Similarly, we can go through this quickly, and you can see this is fx plus g, f plus g of x is not very they are very nice. Okay, but we have a problem here. F by g of x, this is what is square root of x by x, but x is this will be defined only when x is not equal to 0, because x is equal to 0, denominator becomes 0. Okay, So the domain changes from the set of real number minus the point 0. Like this you can go through this exercises. Okay, this exercise is from your class 11, so we are not going to do this. So we'll move to class 12 now. So in class 12 we have to differentiate we have to study few type of functions. The first function is what? F from x to y is defined. Okay, the function f x to y is defined to be a 1-1 function or injective. It is called injective too. Okay, it can be 1-1 or injective. It can be injective. Okay, so 1-1 or injective if what? The image of distinct element of x under f are distinct. Okay, means image of distinct elements means no two point of the domain can go to one point in the codomain. Okay, image of distinct means if 2 points are not equal in x, their image are distinct, image are also not equal. That is, for every x1 x2 belongs to f, fx1 equal to fx2 implies distinct. Okay, if fx1 is equal to fx2, x1 is equal to x2. Okay, that is the thing. Otherwise, what we say, if a function is not 1-1, we say it is what? Many one. Okay. Next, a function is said to be onto or surjective if every element of y is the image of some element of x under f. So every value of y there exists at least one x such that fx equal to 1. This means what? This means range is equal to codomain of f. Okay, range of f is equal to codomain of f. Okay, so that is the thing. So this is the thing. So we'll just see a few examples and try to see the things. Here you have few pictures of function. You see 1 is going to a, 2 is going to b, 3 is going to d, and 4 is going to c. You see every distinct element from x1. Okay, you see distinct element. These are different elements. They are going to say, they are not going to say no two points are going to same elements. Okay, so image of every points are distinct. So therefore this is what? 1-1. Is this onto? No, because you have E and F here which doesn't have a pre-image. So this is what? 1-1, 1-1, but not onto. Not onto. Okay, similarly you see here you have 2 points which is going to same point. So this is what? Not 1-1. This is what? Not 1-1. Means what? This is what? Many one. This is a many one function, and you see you have a point A, E, F which doesn't have a pre-image. So this is what? Not onto. Okay, this is not onto. Okay, similarly you just see here. So you see 1 and 2 is going to A. So this is not what? Not 1-1. This is the many one function. Many one. Okay, is this onto? You see there is no point in x3 which doesn't have a pre-image. Okay, every point have a pre-image. So this is what? A onto function, and you can just see this is what both 1-1 and onto. Okay, a function is said to be bijective for 1-1 onto if it is both 1-1 and onto. Okay, so here are few examples which I would like you to go through the examples yourself and see, okay, what we can do. Okay, here you see if here function is what? Fx equal to 2x. So we have to prove this 1-1 onto. So to prove this 1-1 onto, there is like one algorithm type of thing. Okay, so there is an algorithm. So what is the algorithm? So to prove it is 1-1, what we'll do? We'll start with let fx equal to fx1 equal to fx2. Okay, then we'll prove that x1 is equal to x2. Means what? We'll say that if images are same, then points are same. If I can do like prove this, then this will be what? 1-1. If this thing is true. Okay, you see fx1 we have taken, fx2. Now you plug in the value of fx1. This will be what? As formula of fx is 2x, so this will be twice x1, and this is twice x2. To cancel, you get x1 equal to x2. So therefore, this is what? 1 1. Now given any real number y in R, so we have to find this for y by 2 so that f of y is equal to f of y by 2 is equal to y. Okay, you can just see that. So how to find this y by 2 is the technique. Okay, it's a challenge. You have to do it. Okay, you have to take one y in the set of real numbers. So here to prove on 2 we have to take a y in R. Then you have to find this y by 2. What will be here? So this means like this. Whenever you put a y here, okay, if I can find for any general y a point here, okay, a point in this place such that f of this point is y, then this will be what? Onto, because we have taken this from the codomain. Okay, from codomain we have taken one point y and this arbitrary number, and we have found one number whose functional value is y. So if this thing we can prove, then that will be what? Onto. Okay, that is the trick. So you just see this question number, example number 10. So our function is from n to n. It is given n. What is the function? It is given by that f1 is equal to f2. Okay, and x is equal to x minus 1. Sorry, f1 equal to f2 is equal to 1, and x equal to x minus 2 for every x greater than 2. So is onto but not 1 1. Okay, so we have to show that this is not 1 1. Okay, you can just say f1 is as f1 and f2 are same, therefore this is not 1 1. Okay, because 2 point, okay, 1 and 2 are going to 1, so therefore it is not 1 1. Okay, now for any natural number y belongs to n and y is not equal to 0, you can choose one number, y is not equal to 1, we can take a natural number y plus 1. And what will be f of y plus 1? Okay, because y is not equal to 1 means y will be at least 2. Okay, so if y is equal to 2, what will be y plus 1? It will be at least 3. Okay, whenever it is greater than 2, you have to use this formula. So as now y plus 1 is at least 3, so we have to use x minus 1. So this will be y plus 1 minus 1, so which is equal to y. So we got that for any y not equal to 1, we have a natural number y plus 1 whose image is y. And if y is equal to 1, we can just see that f of 1 equal to 1. So y 1 has a pre-image, 1 has two pre-image, 1 and 2, and other natural number have only one pre-image, that is the predecessor of that number. Okay, similarly you can just go through this example number 11. After 11 I think you have few more, 12 and 14. After 14 we just go through, and in our next class, means it will be day after tomorrow we'll be solving these questions in the live session. Okay, we'll have a Google Classroom class, and in that class we'll solve these problems. Okay, so this much is for today. So it is very essential for you to go through this, because I'm not going to repeat the concepts in the online class. So, okay, thank you.